Hey everybody, it's Merm. This is to go through and practice when you want to redo the 10-week test. This is the packet that you have to do, the practice that's required, and I want to go through it with you. If there's certain things that you really have questions about, you can fast forward to that section. Otherwise, I'm going to start right at the beginning. So, first of all, let me just get inking here. All right, so all about sodium. What is its atomic number? So I grab my periodic table and I look up sodium, which is Na, and the atomic number is 11. And what important information does this tell me about the atom? It tells me that all Na atoms have 11 protons. So the atomic number is really, really important. It's the identifying feature of an atom. It tells me how many protons it has. And no matter what it is, even if it's an ion, even if it's an isotope, every sodium is going to have 11 protons. All right, what is the mass number? Round to the whole number. So I look up in the top right corner and it says 22.9 blah, 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 blah. So I round that to 23. What important information does this tell me? So the mass is equal to the number of protons plus the number of neutrons. So if I have 23, I like to write it like this. The 11 told me how many protons, the 23 is the mass. I can subtract, and that tells me I have 12 neutrons in the nucleus of this atom. All right, next, what is the electron configuration? So I look under the 11 in the box on the periodic table, and it says 2-8-1. So that tells me the first energy level. It tells me it has 3 energy levels. The first energy level holds 2 electrons. The next energy level holds 8, and the last energy level holds 1. Which electrons have the most energy? The outer valence electron. So this one right here, that one has the most energy because it's furthest from the nucleus. What is the nuclear charge? So inside the nucleus, there are 11 protons and 12 neutrons. That's what's inside my nucleus. So neutrons don't have a charge. So the charge would be plus 11 because protons are positive and it has 11 protons in the nucleus. All right, draw the Lewis dot diagram for an atom of sodium. So Na, we said that the configuration was 2-8-1. So I just need to show the 1 valence. So I put the 1 dot right there. That's it. Where on the periodic table is sodium found? So sodium is in group 1. What does this tell you? It tells me that it has 1 valence electron. And then period, it is in period 3. So I look over to the left and the rows across are the period. So I can see that it is in period 3. So that tells me it has 3 energy levels. So remember, those are the large shells that hold the electrons. All right, list one other atom that sodium would have a lot in common with. So I'm going to pick K, potassium. It's right under it. How did I choose it? I chose it because it is in the same group. And what do they have in common? They both have 1 valence electron. So when you want to know who an atom has the most in common with, they always have the most in common with their group because they have the same number of valence electrons, so they're going to behave in a similar way. They do not have as much in common with the period, the group going across, less in common with the period, more in common with the group. All right, what family is sodium in? Okay, group 1 are called the alkali metals. List a physical property and a chemical property sodium has based on this. All right, so a physical property would be that it has luster and that it is malleable and that it is a good conductor. all of those are physical properties based on the fact that it's a metal. For chemical property, I'm going to say that it is a very reactive metal, and it is very likely to lose electrons. Those are chemical properties. That's what happens to it in a chemical reaction. So again, look at that 281. It's really likely to react and lose that one valence electron. All right, since sodium is a metal, left of the staircase, it will, okay, so left side losers. It is going to lose one electron and become a +1 ion. Its electron configuration would change from 2-8-1 to 2-8. When it loses, it actually loses an entire energy level. And so now its configuration is just 2-8, which means it has that full octet and it's very stable. This would give it a charge of +1. Oh, so up here maybe they wanted the word positive. Positive +1, same idea. All right, then it would have the same electron configuration as what element? All right, I know when it becomes stable, it's like a noble gas. So I am going to look and see which noble gas is 2-8. So it's really easy with sodium. If you lose one electron, you just go backwards one. So instead of 11, it has 10 electrons. So that means it's like neon. Ne. And draw the Lewis dot diagram of a sodium ion. Remember, ions always need A, B, C, D. So A, the atom, B, the brackets, C, the charge, D, no dots. It lost its outermost dot. So I do not show any dots on my Lewis dot diagram. All right. Sodium has 18 different naturally occurring isotopes. Each isotope has a different number of neutrons. That's literally like the definition of an isotope. Na23 has, okay, they all have 11 protons. So if it's Na23, it has 11 protons, it has 12 neutrons, and it has 11 electrons. It's an atom, so it has the same number of positive protons as it does negative electrons. All right, Na25, okay, that's still going to have 11 protons, but 25 minus 11, it has 14 neutrons, still has 11 electrons. Na19, so 19 would have still 11 protons, but 19 minus 11, it only has 8 neutrons, still has 11 electrons, right? So each one, the mass showed that there were a different number of neutrons. If there were only 3 isotopes and their masses and abundances are as follows, set up the correct numerical calculation for the average atomic mass and solve to the correct number of sig figs. Okay, we haven't done sig figs yet, so I'm going to have you cross that out. And I'm going to have you do this to the 10th place. Sig figs is something that we will be doing soon. All right, so I want to set this up. I am going to multiply always the mass times the abundance. So I'm going to multiply these together. 23.115 times 84.3 plus the next one, 24.993 times 11.1 plus, and my last isotope, 19.034 times 4.6. Now, because I did not move the decimal, and these are all percentages, I need to divide by 100 to get rid of the percent. And now I'm just going to grab a calculator so I can punch this all in and solve it. So I put parentheses 23.115 times 84.3 end parentheses plus sorry, it's just going to take me a second to punch this all into my calculator. Hopefully you're punching it into your calculator too. 0.34 times 4.6 All right, and then divide it by 100 equals. All right, I got 23.1 if I round it to the 10th place. I want to just look. My NAs are between 19 and 25, and my answer comes out 23. And 23 had the greatest percentage, so that definitely makes sense. You always want to check and make sure, does my answer actually make sense? And then the unit is atomic mass unit. All right, so that's what I got. All right, aqueous sodium ions can be heated in a flame and release bright orange spectra. Explain in terms of energy and electrons how the spectra is produced. So as the excited electrons fall back to ground state, they release energy as spectra. All right, so picture 281. Picture maybe this one outermost electron. Imagine it getting excited. It moves out to an even higher energy level. To do that, it had to absorb energy. And now it is excited. Back here, it was in its ground state, 281. Now, it never stays in that excited state, so eventually it's going to fall back down to ground, and when it falls, it releases energy. And that energy that it releases, those are the wavelengths of color that you see. List a possible excited electron configuration for sodium. So what we just did was 2-8-0-1. A really common one, I would say. All right, so ground is 281. A really common one that I would expect you to probably write is 272, meaning have one from the second shell go out to the third shell. Important thing, check and make sure it still adds up to 11. You did not gain or lose any electron in this process. All right, next one. Sodium readily bonds with oxygen. What would the formula for the compound be? All right, sodium is Na. Na is a +1. Oxygen is a -2. So I've got charge on the left, charge on the right, crisscross, and I get Na2O. What would the name of the compound be? So the name would be sodium oxide. It does not need a middle it does not need a middle name, because if you look at sodium, there's only one possibility of charge, +1. So when it only has one possibility of charge, it does not need a middle name. No Roman numeral needed. What type of bonding? I have a metal with a nonmetal, so this is ionic bonding. What happens in terms of electrons? The electrons were transferred, and they were transferred from the metal. Sodium lost them, and oxygen gained them. And that's why you needed 2 sodiums. Each Na had 1 to lose, and oxygen needed to gain 2, so it needed 2 sodiums. Draw the Lewis dot diagram. All right, up here, the formula tells me how I'm going to do it, and I'm just going to remind myself, it's ionic, so I need A, B, C, D. A, the atoms. I only have 1 oxygen, so I put it in the middle. I have 2 sodiums, so I put them on each side. B for brackets, put the brackets around it. C for charge. Way back over here, I had the charge. NAs each get a +1. Oxygen gets a -2. Stop right there, add them up, and make sure it equals 0. It does. And then D for dots. The dots are the electrons. Na lost electrons, so no dots. Oxygen used to have 6, and now it has all 8. So I show all 8 dots on the oxygen. The following reaction shows the formation of NaCl. Classify each reactant and product and draw a particle diagram of the reactants and the product. All right, so Na is an element. That's how I would classify it. And my justification is it is only one type of atom, And it is also on the periodic table. It's called the periodic table of elements. If it is on there as just one thing, it is an element. Cl2, this is also an element. It just happens to be one of those diatomic elements. It's never alone. Cl is with another. Justification, same thing, only one type of atom, and it is on the periodic table. All right, NaCl is a compound. And the reason why I know it is a compound is because I have two different atoms bonded together. All right, draw a particle diagram for each and make a key first. So I need an Na and I need a Cl. So I think the easiest thing to do is an open circle and a filled in circle. So it says that I start off with two NAs. So I'm just going to draw two NAs in the reactants. And then I need a Cl2. So a Cl2 is a diatomic element, so it looks like that. And then the product was NaCl. So that means these are connected. And it also said that I had two of them. So I'm going to go ahead and draw two of them. All right, how could you make salt into a homogeneous mixture? You could add water. Is this a physical change or a chemical change? It is physical. And justify your answer. It has not changed composition. I could do evaporation to get the water and the NaCl back. All right, and then I just want to write it over here so that you see it. When it's NaCl, AQ means aqueous, and it means that it's mixed well with water. All right, now we're moving on. B, chlorine. Chlorine is one of the 7 diatomic elements. It does not exist on its own. There are not other atoms available for it to bond. If there are not other atoms available for it to bond, it will bind to itself, forming Cl2. So that's what it means by diatomic. The other ones, just so you know, it makes that little saying, I always say 7 up. So you start with the N and go across and make the number 7. So N, O, F, Cl, Br, I, and then up in the corner is H, H2. So I put 2's next to all of them to show that they're diatomic. And if you count them, 1, 2, 3, 4, 5, 6, 7. There are 7 of them. All right, draw a Lewis dot diagram for an atom of chlorine. Okay, 1 chlorine, I do the Cl. I look up the electron configuration and it's 2-8-7. So I want 7 valence electrons on it. 1, 2, 3, 4, 5, 6, 7. There, I've put them all in the right locations. And now it says, draw the Lewis dot diagram for a molecule of chlorine. So if you would like to loop the lonelies, you can go over here, do your chlorine with your 7 dots, do another chlorine with its 7 dots, and then loop the lonelies. That shows you 1 bond between them. So my final answer, 1 bond between a chlorine and a chlorine, and there are 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 unshared electrons on each chlorine. I need to put those back on. So I go around the outside, I put those electrons back on. So by sharing, they are able to both be stable. So what type of bonding? This is covalent bonding because they are sharing electrons. All right, is the bond polar or nonpolar? It is definitely nonpolar. And the reason why is the electronegativity difference is equal to 0. I don't even have to look up the electronegativity of chlorine because the value of chlorine minus the value of chlorine is going to come out 0. And now, is the molecule polar or nonpolar? So it is very even. It is very symmetrical, which means that there's no pulling, so it's also a nonpolar molecule. Remember, it's very different if you're asked the polarity of the bond versus the polarity of the molecule. For the bond, you have to look up electronegativities and figure out the difference. For the molecule, you're looking for the distribution of electrons. Is it even and symmetrical or uneven and asymmetrical? All right, chlorine forms blank compounds when it bonds with a metal. All right, when it forms with a metal, it forms ionic compounds. For each metal, write the formula and name of the compound that it forms. Then draw the Lewis dot diagram of the compound. Okay, so I want aluminum and chlorine. So Al, I go look it up, it's a +3 ion. Chlorine, Cl, is a -1. I crisscross, and my formula is AlCl3. The name of that would be aluminum chloride. The drawing would have to show atoms, brackets, charges, dots. So I need 1 Al and I need 3 Cls. 1, 2, 3. I need brackets around everybody. I need charges. -1, -1, -1 for my Cls. +3 for my Al. I make sure it adds up to 0. It does. Chlorine gets all 8 dots because it now has gained that 8th dot from the aluminum. So it is now stable. All right, calcium. Calcium, Ca. I look it up on the periodic table, and in the top right corner, it tells me that it's a +2 ion. Cl is a -1. Crisscross. And I get CaCl2, which is calcium chloride. Again, it's ionic, so I need ABCD. 1 calcium, I follow this formula. 2 chlorines. Always separate your ions, positive and negative, from each other. Put brackets around each one. Put the charge on everybody. Make sure the charge adds up to 0. Put the dots around the negative ion. All right, manganese 4. That tells me Mn is a +4 and Cl is a -1. Crisscross, MnCl4. Manganese 4 chloride. Ooh, I'm going to need some room. All right, hang on one sec. All right, left off my E. All right, so I'm going to have to draw pretty small. I need an Mn here in the middle, and I need 4 chlorines. So I'm going to put 1 on top, 1 on the right, 1 under, and 1 on the left. They all get -1s, and the Mn gets a +4. I make sure it adds up to 0. It does. Chlorine gets all 8 dots. Okay. Chlorine forms a blank compound when it reacts with oxygen. So chlorine is a nonmetal, oxygen is a nonmetal. So this is a covalent, or we could also call it molecular. Covalent, molecular, a molecule, same thing. All right, write the formula of the compound that forms and draw the Lewis dot diagram. All right, so I need chlorine and oxygen. So remember, when I do this, I loop my lonelies. So chlorine has 7, oxygen has 6. 1, 2, 3, 4, 5, 6. That tells me I have 2 openings. So 1 chlorine here, I'm going to need another chlorine here. It also tells me that when I do my Lewis dot diagram, I need to show those 4 electrons are not being shared. 1 chlorine goes to the left and 1 chlorine goes down. Put the other unshared electrons back on the chlorine. My formula would be OCl, 2 of them. And we are not naming those for this year. All right, is the bond polar or nonpolar? All right, I'm going to look up O. I'm going to look up Cl. I'm looking up their electronegativity. Bonds always require me to look up electronegativity to figure out polarity. So O is a 3.4. Cl is a 3.2. So the difference between them is 0.2. So that is non-polar because it is less than 0.5 electronegativity difference. To be polar, to be a significant pull, the difference has to be larger than that. And then is the molecule polar or non-polar? So this is a polar molecule because it has an uneven distribution of electrons. The molecule is bent. It is showing that the oxygen has these unshared pairs of electrons over here, so it is asymmetrical. All right, compare ionic and covalent bonding. So ionic is between a metal and a nonmetal. Ionic, the electrons are transferred from the metal to the nonmetal. The Lewis dot diagrams have to have atoms, brackets, charges, and dots. And the properties of an ionic compound is that they are usually hard crystals. They dissolve in water. They have high melting points and boiling points. And they can conduct electricity as a liquid or an aqueous solution. All right, covalent. This is only between non-metals. What happens to electrons? They are shared. How do you draw the Lewis dot diagrams? You show the bond as a line. That line represents 2 electrons being shared. So if you have a double bond, you're going to have 2 lines and you're going to have 4 electrons shared. And if you have a triple bond, you have 3 lines and you have 6 electrons being shared. All right, the properties. If it's a solid, it's soft. It's very often a liquid or a gas. They do not dissolve well. And they are what we call poor conductors. And they have relatively low melting points and boiling points. Think about it. Many of them, if it's a gas already, you already passed the melting point and passed the boiling point. All right, write the name or formula for each, identify if it's ionic or covalent, and draw the Lewis dot diagram. All right, Ni and O. The first thing I always want to do is right here, is it an ionic or is it covalent? It really helps me with the name and it helps me with the Lewis dot diagram. So Ni is a metal and O is a nonmetal, so this is ionic. So the name, well, first of all, I've got to remember that O is a -2, which means my Ni is a +2. So the name is nickel. And then if you look up nickel, nickel has possibilities of charge, which means that I need to show that the charge was a 2 in my name. Nickel 2. Nickel was a +2 charge. And then oxide. And then when I do the Lewis dot diagram, I just have one Ni and one O, because that's exactly what my formula showed. I have brackets. The charge on this is +2. The charge on this is -2. I make sure it adds up to 0. And then I put all 8 dots around the oxygen. All right, TiCl3. So that 3 came from up here. So the titanium was a 3. I look at the periodic table. Titanium does have multiple choices. So I have to show a middle name. Titanium 3 was its charge. Chloride. This does have a metal and a nonmetal, so it's ionic. And then when I go to draw it, 1 Ti, 3 Cls. They all get brackets. Cls are all -1s. Ti was a +3. I make sure it adds up to 0. And I put all 8 dots around my chlorine. Okay, next one. HBr. So I have no metal. So right away, this is covalent, which means I don't have to name it. H has 1, Br has 7 valence electrons. I can loop the lonely. It shows that I have 1 bond between them. So I show the H and a line to the Br. And then Br has 6 unshared pairs of electrons, or 3 pairs, 6 total electrons. So I show it like that. All right, AlPO4. I don't need to draw it. Al is aluminum. Aluminum is only a +3, so it doesn't need a middle name. PO4 is a weird thing, so I have to go to table E, and I got to figure out what the name is. So, sorry, I'm just flipping over here to table E. All right, on table E, I see that PO4 is phosphate. And they canceled each other out. Al was a +3, PO4 was a -3, those canceled out. When you have a metal and a polyatomic ion, it is ionic. And then the P and the O are actually 2 nonmetals. So this one is actually both ionic and covalent. Something new there. We actually haven't talked about that yet. All right, CH3F. Okay, that is covalent. I have no metal, which means I don't have to name it, and I have to show the sharing. Well, every time I have carbon, carbon goes in the middle. 3 H's. I put one on 3 sides. It really doesn't matter if you put it on top or bottom or where you put it. And then I need an F. So the F would go here. Now, fluorine had 7 valence electrons, so I need to show the 6 that aren't being shared around it. The 7th one is right here on this line with this bond. All right, next. Fe2SO43. All right, the 3 came from the iron, the 2 came from SO4. I go look it up. SO4 is sulfate. All right, so the name of this would be iron 3, because it's a middle metal. I have to show its middle name. And then SO4 with a -2 charge, sulfate. And again, this is both ionic and covalent because you have metals, you have nonmetals all bonded together, and you don't have to draw them. All right, NH3. There is no metal in there, so this is covalent, which means I don't need to name it. When I draw it, I'm going to put the N in the middle, and I'm going to put 3 H's around it. And the nitrogen had 5 valence electrons, so I have to show the 2 that are on the top as well. And then water, this might be our last one. Oh, no, not yet. Water has no metal, so that's covalent. I don't need to name it. I draw the O. I show the unshared pair of electrons, and I would have an H bond over to the left and an H bond below. All right, and then CuO. There's our last one. So that's a metal and a nonmetal. So this one is ionic. O, I know, is a -2, which means copper had to be a +2. I go look up copper. It has more than one choice, so I have to write a middle name. Copper 2 to show that it was a +2 charge, oxide. Now, because it's ionic, when I draw it, I do the Cu and the O, just like the formula says, 1 Cu and 1 O. I do the brackets. I do the charges, +2, -2, and my oxygen gets all 8 valence electrons. Okay, so I know that that was a lot that we just went through. Please take the time to practice, make up problems, go over it over and over and over until you feel really confident. And if you would like more practice, just let me know. I always have more practice that you can do. Also, make sure you ask questions. If there's something that I went over too quickly or something that you got wrong on the test that I didn't put in this review, please ask questions. I have office hours every Wednesday, and I am happy to help. Bye, guys.